Hey guys, welcome back to Mathin' with Coach Lynn. Today we're going to cover Lesson 2.2, percents greater than 100% and less than 1%. On page 93 is where we begin Lesson 2.2 in our Tennessee Reveal math book. We have an I can statement that states, I can understand that percents can be greater than 100% or less than 1% and use a 10 by 10 grid or bar diagram to represent them. We have our learn, which goes over percents greater than 100%. We have a table that shows the rainfall for a certain city for 3 years, and we see in 2017 it rained 4 inches. In 2018 it rained 3 inches. 2019 it rained 5 inches. I'm going to skip on down to the middle of the page where we look at percents greater than 100. And in 2019 it rained more than it did in 2017. To compare the rainfall in 2019 to 2017, we need to compare how much rain came down, and we look at it as a ratio. Okay, we see the ratio is a 5-to-4 ratio because we're doing 2019 to 2017. So we need 2019's number first, which was 5 inches, and then 2017's number, which is 4 inches. We can also write our 5-to-4 ratio as 5-to-4. That looks like a fraction, 5/4. And we know if we need a percent as a fraction that is over 100, because percent is per 100, as we discussed previously in Lesson 2.1. So for us to go from 4 to 100, our known value on the bottom, 4 times 25 gives us 100, so we need to figure out what our top number will be, and that would be 5 times 25, which give us 125. So we have 125 per 100, which is the same as 125%. So now at the bottom of page 93, we can see 125% modeled using a 10 by 10 grid. Now if we notice, it looks a little different than what we saw in Lesson 2.1. We have 2 10 by 10 grids. This is because we are looking at percents greater than 100. So one 10 by 10 grid we know contains 100 squares. And in this model, we have one that's full. That represents 100%. And then we have a second 10 by 10 grid that has 2 columns and 1, 2, 3, 4, 5 of the next column, which gives us 25. So we are modeled with 125%. Now let's do an example of modeling using a 10 by 10 grid, and let's look at page 94 where it says what percent is represented by the 10 by 10 grid. I see that I have one whole 10 by 10 grid, so we know this one is 100%. And then I have 1, 2, 3 full columns, so that's 30. And then 1, 2, 3, 4, 5, 6, 7 in the next column. So we have 37% there. So I have 137% represented in my 10 by 10 grid. Other times they may ask us to model a percent. And we see in this check problem on page 95, it says, at birth, a male baby giraffe stands almost 6 feet tall. At 4 years of age, the male giraffe will be about 3 times as tall as at birth. Write a percent that compares the giraffe's height at 4 years of age to its height at birth. Then draw and shade a 10 by 10 grid to model the percent. Okay, so we see that the baby giraffe is 6 feet tall at birth, and at 4 years of age, they tell us that it'll be 3 times as tall as that. They want us to write a percent that compares the height at 4 years to the height at birth. Okay, so we know it's going to be 4 years height to its birth height. And we know that we can write ratios like fractions, so we're going to go ahead and do that now since that's what we're going to need to get down to do our percent. So at 4 years, we're not sure what the height is, but we do know at birth it is 6 feet tall. It tells us that it will be 3 times as tall at 4 years old. So 6 times 3 gives us 18. We know if we need to figure out a percent, we know percent is per 100, so our denominator needs to be 100 when we do equivalent fractions here. Now when I look at this, I see 6 and 100, and I think to myself, do I know any number that I can multiply 6 by to get to 100? Well, no, there's not any. So the easiest thing for me then is we're going to take what I've learned from ratios in Module 1, and I'm going to scale back. So if I go backwards, I can divide 18 and 6 both by 3. 18 divided by 3 is 6, and 6 divided by 3 is 2. I have an equivalent ratio now to 18 to 6. It's 6 to 2. They equal the same things, and that's why I can find the right percent I need to represent my problem. 2 times 50 gives me 100. So I'm going to do 6 times 50, and that will give me 300. Since I have 300 over 100, I know that that's 300 per 100, which is 300%. Now on page 96, we're going to look at percents less than 1. It tells us at the top of the page that percents can be represented by less than 1. And they give us an example where we have the radius of the earth compared to the radius of the sun. And they tell us the radius of the earth is 4,000 miles and the radius of the sun is 430,000 miles. And we know that if we want to find the percent to compare these two numbers, we need to get to a fraction with a denominator of 100 to get per 100%, find our percent. So for me to get to 430,000 to 100, I need to divide by 4,300. An easy way for me to figure out what I need to divide by when I'm going to percents less than 1, when I'm going from a bigger number down to 100, is I can move my decimal 2 places to the left. So if I move my decimal 2 places to the left in this number, I see that I have 4300.00. So that's 4,300. So I know I'm dividing by 4,300 on the bottom to get to 100. So I'm going to divide by 4,300 on the top, and I'll get 0.9302 and some more numbers. But for our case, we want to just round to the nearest hundredth. So we get 0.93 per 100, which is 0.93%. Now at the bottom of our page, we look at modeling that 0.93%, or 93 hundredths of a percent. And we see here that they take a zoomed in shot of our 10 by 10 grid. We know a 10 by 10 grid has 100 squares in it, and it represents 100%, and 1 square represents 1%. So when we zoom in, we see 100 tiny squares. Each one of these squares represents 0.01%, or 100th of a percent. So for me to represent 93 hundredths of a percent, 0.93%, I need to have 93 of these tiny little squares colored in. If we zoom in, we can see that there's a little sliver of white in our box right there. That shows us it's not a full whole number, which 0.93 is not a whole number. It's not 1 whole percent. Now let's look at the check problem at the bottom of page 97 and use what we've learned so far and apply it. They ask us what percent is represented by the 10 by 10 grid. So we see that it's going to be something less than 1% because it's not one full square within my 10 by 10 grid. I look at my smaller 10 by 10 grid, which represents my hundredths. We know one of these squares is 0.01%, or 100th of a percent. So I need to know how many of these are shaded, and that will tell me how many hundredths of a percent I have. Well, it's the same concept as my normal 10 by 10 grid. There's still 10 by 10 here. So if I have a full column or a full row, that's 10, and then I can just count my partial rows or partial columns. In this case, I have 1, 2, 3, 4, 5, 6, 7 full columns. So I know 7 times 10 is 70. So I have 0.70% or 70 hundredths of a percent, but that's not quite how we want to write this number. This 0 is very unnecessary. It'd be like me writing 0.7 for the number 7. I don't need that 0 there. So I want to write this percent that's represented by 0.7% or 7/10 of a percent. Or we could still say it as 70 hundredths of a percent, since we know it's 70 of the 100th tiny squares that make up a whole percent. On the bottom of page 98, they want us to take a problem, calculate the percent, and then model it with the 10 by 10 grid that they give us. It tells us the average weight of a brown bear is about 1,000 pounds. Suppose a large stuffed bear weighs 2.5 pounds. You want to write a percent to compare the weight of the stuffed animal to the weight of the brown bear. Then use the 10 by 10 grid to model the percent. Stuffed animal to the weight of the brown bear. Okay, so I got stuffed animal to the brown bear. Like before, we'll go ahead and write it in fraction form so we can get to where we want to with our percents. And through my problem, it tells me that the stuffed animal weighs 2.5 pounds, 2.5 pounds. And the brown bear, is 1,000 pounds. Okay, so I want to get to a percent to compare them, so I know I need a fraction with a denominator of 100. So I need to get to 1,000 to 100. Like earlier, if I need to go from a number to 100, I know I can move my decimal to the left 2 times. So if I do that, I'm going to get 10. Okay, so divided by 10, 1,000 divided by 10 gives me 100. So I'm going to do 2.5 divided by 10. And that will give me 0.25. 0.25 per 100, which is 0.25%. And if I have 0.25%, that's the same as 1/4 of a percent. So if I need to shade a box, I'm going to shade 1/4 of my box to represent 1/4 of a percent, since I do not have a whole percent. Number 1 wants us to find the percent that's represented by the 10 by 10 grids. And we see that we have one whole grid, which we know is 100%. And then we have 10, 20, 30, because we have 3 full columns. And 1, 2, 3, 4, 5, 6. So we have 36% represented there. So altogether, we have 136%. On number 3, we do the same thing. We want to see the percent represented by the 10 by 10 grid. And we see it's a zoomed in version of a 10 by 10 grid. So we know it's going to be a less than 1% that's represented here. So I'm going to look at what is shaded. I have 1, 2, 3, 4, 5 full columns. Okay, so I know that's going to be 50. And then I have 1, 2, 3, 4, 5 going up, and then also 1, 2, 3, 4, 5 going over. So I have a 5 by 5 area that's shaded. 5 times 5 is 25. So I've got 50 plus 25. So I have a total of 75 hundredths shaded. So that would be 0.75% or 75 hundredths of a percent. Or we could also call it 3/4 of a percent, and we see there that 3/4 of our box is shaded. 5 tells us the size of a large milkshake is 1.4 times the size of a small milkshake. Write a percent that compares the size of a large milkshake to the size of the small milkshake. Then draw a 10 by 10 grid to model the percent. So they tell us this large milkshake is 1.4 times the size of the small one. So we know it's 1.4 times of the small one. But it doesn't tell me the size of the small milkshake. But I do know that it wants me to compare and find a percent of the large milkshake to the small one. So I have the large to the small. I know eventually I need to figure out a percent, so I need to get to a fraction over 100 per 100%. So in this case, I can give the value to the small shake whatever I want, because no matter what value I give the small shake, the large one, as they told us, is going to be 1.4 times that size. So the easiest thing for me is going to be to get a value that will multiply into 100. So to do this, I could use the number 5. If my small shake is 5 ounces, do 1.4 times 5, and I will get 7 for my large shake. 5 times 20 gives me 100. 7 times 20 gives me 140. So I have 140 per 100, or 140%. So my large shake is 140% the size of the small shake. I hope what we've done today is helpful for you. You're able to take these concepts and move forward as we go through Module 2.